Continuing to look at lines, again, something you've looked at many times before. This has got more of a college algebra kind of language to it, but underneath that language is all the same stuff you've seen. Now, this is really all the way back to something you've done many times when you first learned about lines. The only thing you need to remember here is the function notation is y. That would be the only thing I think that would cause you to have difficulty. Now the problem with these questions, by doing this by plotting points, you'd make the x and the y table. If you have this in this form, that really is kind of silly because you know the y-intercept is 5, and then you would go down 2 over 3. But just showing you this real quick, this is the old school. You'd make a table, you'd pick some values for x. You can pick anything you want. Notice they're picking values that are going to make the calculation easier. By picking 0, of course, this would drop out. By picking 3, the 3 and the numerator and the denominator would cancel. By picking 6, it would reduce. You see, so they've just picked some clever numbers and plotted them, and then you have the line. So I'm not going to graph all this out here because we're going to do this by the slope-intercept. Most all students would. There's my slope, there's my intercept. But so if I were plotting points, I'd always pick 0 because that would make the x part all drop out. I would then pick 4 because 4 for the x and a 4 in the denominator would cancel. And then I'd pick 8. A lot of times, or sometimes maybe I'd pick -4 so that the same trick would cancel and I would get the two negatives to cancel. But that's the same idea. I'm not going to crunch all that because what we're going to do, if we have to do this, remember this is just y. I've got my y-intercept. So I'm going to start at 5. That's what the slope does, or the y-intercept does for us. It allows us to build this whole thing off just this one equation. So I've got my first point. Now my slope is -2 over 3. Now remember, I mentioned this in the last video. You could think of this as any of these. These are mathematically equivalent. So we could think of this as being down 2 over 3. Down 2 over 3. So mark a couple of those points, connect your line. Now the next screen I think is going to ask this question, well what if we had wanted to go back the other way? What would we do? Well, we'd use it written the other way. So instead of down 2 over 3, we could give the negative to the bottom and make it up 2, 1, 2, back 3, 1, 2, 3. And we could have gone that way. Okay. What they're saying here is true. I make these out of order, so I don't know if we've talked about transformations yet. I can't remember what chapter it's in. But there really is just one basic line. It's the line y equals x. And you can think of this as all being just transformations of this line. Now, again, I'm not sure if we've talked about this, but if you have a negative on the end, what's on the end here just moves the line up or down. So if it was +2, I would just take that basic line and I would move everything up 2 spots. Well, here if it's -3, I'm taking that basic line y equals x, which is just up 1 over 1, up 1 over 1, and going through the origin. That's y equals x. And I would just move it down 3. That's what this transformation does. Now, if you have a value in front, out here, in front of the whole function, then it's a, let's see. If you have a number in front there, this could be either a stretch or in this case a compression. It's either going to take that line and like stretch it up, magnifying every single value, or it's going to compress every single value by making it a smaller number. So here's their picture. We have the original identity function. What they've done is they have compressed it by multiplying everything by 1/2, and then they've moved it down. Now, this is clever to know, but I wouldn't really ask you to do this at this point. We have a whole section on transformations. But just to talk it through here, so this is going to move that line, and it's going to move that initial identity up 2, or up 4 rather, I should say. It's going to move it up 4. And this is going to stretch everything by 2. So if the original equation was 1, 1, like going through these points, What this is going to do is it's going to magnify everything. So the x would stay the same, but the y is then going to get magnified, and it would become 1, 2, 2, 4. We're multiplying all the y values by that too. So again, I don't know the order that we did this here, but actually what you would do is you do the compressions or stretches first, and then you add 4. So again, I'm just explaining this, but this is not something I would expect in this chapter. But so if you're doing this in order, then you do the ups and the downs last. So what I would do if I were doing this, here's my original points from the identity function. I am multiplying all of those y values by 2. And then once I'd have that new line, which has now been stretched, I would then move that new line up. So now I have points at 1, 2, 2, 4. So I've now created this more tilted line like this. I would then move that new tilted line up 1, 2, 3, 4, 1, 2, 3, 4. And there's my final line. Again, it's clever, but not really essential at this point. We'll talk more about that with transformations. Okay, so they want us to just match some lines here. So first of all, let's just do some identifying. 3 of these lines have a y-intercept of 3. So they hit at 3. This is the only one that doesn't. So this green line here is going through -3. So B has to be that green line, which is number 2. Okay, so the rest of them are going through this point. Let's take a look here at the slopes. This slope is 2 over 1. So if I'm going through here, which one goes up 2 over 1? Well, that's this red one. That's number 1. Okay, this one starts at 3 and has a slope of -2 over 1. So it's here, goes down 2 over 1. Okay, well that's 4. And then 1/2 is my slope here, so I got 1 over 2. So starting here, it means I go up 1 over 2. That's the orange line. That's number 3. Okay, intercepts. So the x-intercept occurs when, so if I had a picture, let me see. So the x-intercepts occur, all of these are the x-intercepts, here, here, and here. X-intercepts occur when there's nothing happening in the y. You're not going up or down at all. So x-intercepts happen when y is 0. So this is the y. I'm just going to set that equal to 0. And now solve it for x. So just some basic algebra. I get this, 6, 0. Okay, let's find the intercept for here. That happens when y is 0. This is y. Okay, solving this. Now, to get rid of 1/4, you can just multiply both sides by the reciprocal, by 4. I get 16 equals x. Now, an intercept is a point. I should have mentioned this on the last screen. So don't just tell me x is 16. It is a point. It is the point 16, 0. Okay, how about the equation of this line? Well, a horizontal line, here's what this means. The y is always 4. No matter what x is doing, you always get y is 4. Well, this is the equation of a horizontal line. Y is always 4. We're just going to change it to fancy function notation, and we would get this. Oh, I'm sorry. I did all this and can't read it because the negative sign is blocked. All of these are -4. It's running through the line -4. Okay, now how about the equation of this line? Well, vertical lines are where x is always equal to some number. And in this case, x is always equal to 7. Now this is not a point or a solution. This is a line. X is always 7. All right, I think we have one more section on the lines here, I believe. So hopefully, again, this is all stuff you've probably seen before, just kind of wrapped up in the more difficult notation of functions.